Okay, very excited for our guest today. He is Thomas Seyfried. He's a professor of biology, genetics, and biochemistry at Boston College. He received his PhD from the University of Illinois Urbana-Champaign. I went to Illinois State, and
so did I.
Oh no!
Yeah, I got a master's degree there.
Oh, no kidding! Fantastic. While his postdoctorate fellowship studies were in the Department of Neurology at the Yale University School of Medicine, where he served as an assistant professor in neurology. He sits on several editorial boards, including those for Nutrition and Metabolism, Neurochemical Research, and the Journal of Lipid Research, and ASN Neuro, where he is the senior editor. Dr. Seyfried has over 150 peer-reviewed publications and is the author of the book right here, Cancer as a Metabolic Disease, on the Origin, Management, and Prevention of Cancer. Welcome to the show, Professor Thomas Seyfried. I appreciate you being here.
Oh, thank you very much, Jimmy. It's nice to be here.
So I was introduced to you. I was on a plane ride. It's so funny. I was on a vacation in Hawaii, and I was talking to Ed Dowd, who's done a lot of work on excess deaths, and he comes from the financial world. And we're talking about all the lies we've been told about medicine and things that we can't really wrap our minds around, how it's been so corrupted by money. And he looks at me and he goes, I bet there's a cure for cancer out there. And I was just like, oh, come on. They wouldn't hide that. Well, on the way home on that plane, I come across this video on YouTube, and it's this professor, and he's talking about how he's been dealing with cancer. And it sounds to me like he's got a pretty good hold on how to deal with it. So tell me, what is your ideas on cancer and how to treat it, because you treat it by starving it. So talk about how you do that.
Yeah, well, thanks, Jimmy. Well, listen, about having a cure for cancer, I don't profess that at all. I think we have better ways to certainly manage cancer, better than what's currently being done. I consider the term cure as kind of arrogant. It's been kicked around for so long as if it's going to be something like a cure for measles or a common cold or something like this. I think we should look at it as more of a more logical management based on the science. Whether that leads to a complete a resolution of someone's cancer, that's all well and good. I mean, we can have that with the current strategies that we're using right now. We have so-called millions of so-called cancer survivors, but they also pay a serious price sometimes for their survival in the form of many other comorbid character traits that they would have gotten from the treatments. Our approach is based on the hard science of what the nature of cancer is, and I'm standing on the shoulders of Otto Warburg, who in the 1920s defined what the nature of cancer was. And he was the dominant force in this field for decades and decades in Germany. He's one of the great thinkers and doers of the 20th century. But he was thrown under the bus, so to speak, when Watson and Crick discovered that DNA is the code for our lives and for genes. And they found mutations in cancer cells, and everybody ran off chasing that and pretty much left Warburg behind. But we were seeing really remarkable effects with calorie restriction and metabolic therapy. When the term starving them, I guess you could use that term with some caveats. Where our research and that of many others have shown that these tumor cells cannot live very long without the sugar glucose or the amino acid glutamine. Warburg knew glucose was the prime fuel for cancer, but he knew nothing about the glutamine issue. And he also did not know about what we call now the third form of energy for cancer, and that's a amino acid fermentation based on the amino acid glutamine. So we can clear up a lot of the mystery and a lot of the problems that Warburg had, and bring the entire cancer field back onto the right track where it should have been 70 or 80 years ago. And as you can see, that we have not made any major progress in reducing the death rates for cancer. mainly because the theory under which the disease is viewed is incorrect. It's not a genetic disease, as the National Cancer Institute and the majority of institutes around the world think. It's a mitochondrial metabolic disease. And once you realize that, the treatments and the lives and success will be greatly improved.
So your approach to it, you don't approach it as a genetic disease. You approach what I've heard you say is this thing about the two fuels that are needed for a cancer tumor, and those two fuels are glucose and glutamine, right?
Mm-hmm.
And
Mm-hmm.
so how do you treat that then? So what is your approach?
Well, our approach, and I learned this from my decades of working at Yale with the epilepsy foundations, where they use ketogenic diets to stop epileptic seizures. It's one of the most common natural forms of managing epileptic seizures in children. Well, we had parallel studies going on in our lab with epilepsy, preclinical studies of epilepsy, as well as preclinical studies of cancer, but they weren't overlapping. One was done independently of the other until we realized that when we started to calorie restrict some of the animals that we had with tumors, we were seeing dramatic reduction of tumor growth. And then we decided to use because Warburg said clearly that these tumor cells are dependent on a very poor fermentation, which is energy without oxygen. And he said that, he was repeated. That's one of the interesting things about cancer cells. They can grow without oxygen. And that oxygen comes from fermentation. It's an ancient way of getting energy. This is how all organisms existed on the planet before oxygen came into the atmosphere 2.5 billion years ago. That we were an anoxic environment on this planet for eons. But the cancer cell, interestingly enough, can live without oxygen. So I said, Warburg said, well, what are they using? Well, they ferment. Well, what do they ferment? They ferment the sugar glucose, and they produce a waste product of lactic acid. So what we did, when we were doing our epilepsy work, we were noticing that if we restricted glucose in children or in our preclinical models, we would get management of seizures. But, it turned out that you'd say, well, then you have to do water-only fasting and all this. Well, this is the way the ketogenic diet started in 1921 at Mayo Clinic. They said, well, children or people with epilepsy, if they stop eating and just drink water, the seizures would go away. But this is not a long-term solution to the problem. So they developed a ketogenic diet in 1921 for epilepsy. And it was lowering blood sugar and elevating ketones. And no one to this day really understands how that's blocking epileptic seizures. But for cancer, it becomes very, very clear. The tumor cell can't live without the glucose, and because they ferment, they can't use ketone bodies or fatty acids as an alternative to glucose. So you can checkmate them. And this is the way a lot of people were using this. The problem is some of these things weren't working. And that's because they also can sneak in the amino acid glutamine, which no one really knew about. They knew glutamine played a role, but they didn't know it was fermented. That's one of our big contributions to the cancer field, that there's another fermentable fuel, a fuel that can provide energy without oxygen, and that's the amino acid glutamine, which is the most abundant amino acid in our bodies. So how do you target glutamine without harming the rest of the body? And that's why we developed the press pulse therapeutic strategy, where we can hold down glucose. We don't need glucose. The brain can transition to ketone bodies, and the heart can transition to fatty acids, but the cancer cells cannot transition. So they are locked into these fermentation pathways. So the solution to the cancer problem, I don't want to say a solution, I would say the most likely and successful management would be to restrict the two fermentable fuels while transitioning the entire body over to non-fermentable fuels, which all of our normal cells can use quite effectively. We evolved to use alternative fuels to glucose. Our Paleolithic ancestors were mostly in a state of ketosis, which is low glucose and elevated ketones, because there weren't delicatessens on every corner during the Paleolithic period. So our species evolved in a starving environment, and we're bringing the body back into those environments simply to restrict and target and gradually degrade the growth of the tumors without toxicity. This is the key thing. We can do that without toxicity. It's very effective if people know what to do and how to do it. And we're writing protocols to do that now.
So just just let me see. Let me try to sum up, and you tell me where I'm getting it wrong or right. So the cancer tumor it has two forms of fuel. One of them is glucose, one is glutamate. So if you stop eating things that produce glucose, meaning sugar, carbohydrates, things like that, you can take that fuel away from the tumor, and then it could also use glutamate. Now, glutamine. Thank you. Yeah. Okay, so glutamine. Now, where does glutamine? What food source has glutamine in it?
Well, that's the issue. You cannot target glutamine with food sources. It's synthesis. It's considered a non-essential amino acid. The body can make it. So it's not. That's why we know that one of the drugs we use is 6-deoxy-norleucine. It's called DON, D-O-N. The structure looks almost identical to glutamine. The problem is it's taken up in the cells and it kind of gums up the entire metabolic pathway for glutamine, and the cell can't use it. Now, they used that drug years ago in oncology clinics and said it was too toxic. They used it did pretty well on leukemias in little kids, but they didn't know how to use it. We have all of these tools in the toolbox, but you really have to know how to use the tool to make it work right. We use the tool in a calorie restricted ketogenic diet, very low doses of glutamine now. So its power is there, but its toxicity is significantly reduced. So it's, again, if you know how to use the tools in the toolbox, you can get tremendous results. And the folks that were using DON in the past were just giving patients massive doses of this without also targeting the key metabolite glucose. So the tumor cells were still allowed to grow because you were hitting the more minor component rather than the major component. So you take away glucose with calorie-restricted ketogenic diets, and then you take small doses of DON and hit the glutamine pathway. So this makes perfect sense, and it works really, really well.
So it sounds like you're really onto something. And again, this isn't some kind of fringe theory. This is based on decades and decades of research. And now, is it true that the drug you're talking about, so you change the diet and you get rid of glucose, and then you take a drug, it's called DON, that's the name of it? Now,
it's a glutamine analog, meaning that the structure of DON, in fact, it was isolated as an antibiotic years ago. They thought it was some sort of an antibiotic. So it's a natural compound, but it has a structure very similar to that of glutamine. But the problem is when it's taken up in the cell, it blocks the glutaminolysis pathway, so you can't get energy or nitrogen. Cancer cells need nitrogen to make DNA and RNA. So they need the glucose for metabolite synthesis, lipids and proteins, and they need the nitrogen from glutamine to make a growing cell. So we're pulling the plug on both of the two key fuels that these tumor cells need to use. But we need drugs to target glutamine. The only thing I know to target glutamine minimally is exercise. So if people do a good exercise, the late George Cahill from Joslin Diabetes Center here in Boston showed years ago that glutamine, heavy exercise, good walking, and this kind of aerobic exercise could lower levels of glutamine. But it's not to the level that it certainly helps. But then when you push a little bit of DON on top of an exercise person who's in therapeutic ketosis, man, the problem is not only does the cancer get hammered, but so does the type 2 diabetes, cardiovascular disease, hypertension, high blood pressure. Well, all those kinds of things start disappearing along with the cancer cells.
So now this drug DON, is it readily available? Are doctors able to get it and prescribe it?
No, that's one of the great tragedies. And, there's some companies in China that make it. I'd like to test everything thoroughly before I rely on anybody. I get it from Chemical Supply where they say not for human use, but it certainly works. And the problem is it should be the singular most available drug for cancer because we've shown how we get rid of the toxicity that everybody was afraid of. So, and when you look at the level of toxicity, it's nothing as toxic as some of the stuff we're giving to the poor patients today. So, and we found a way to keep the therapeutic efficacy while removing the toxicity because we know now how to use the tools. Once you know how to use the tools in the toolbox, you can start making tremendous. Now, it's not that people say, oh, they have a cure for cancer. Let's be honest. We have a lot of ways to manage cancer. The problem is a lot of people just don't know how to use the tools that we have.
So go ahead.
But I'm saying some of the drugs that we use for managing cancer, some of these incredibly toxic drugs, we can use much, much lower doses of these things if the patients are in therapeutic ketosis. We don't need to use these incredibly toxic things that have off-target effects. This is the key thing. Off-target effects damage your gut, your immune system. They damage all kinds of other physiological systems that we need to be a functional, healthy individual. So if you know how the weaknesses of the tumor cell, you can selectively target and kill them without harming the rest of the body. If you know first of all, you have to know that cancer is a mitochondrial metabolic disease. And what I'm saying makes perfect sense in that sphere. But if people think cancer is a genetic disease, then you treat people with all these kinds of things that really don't work.
So, why do you think? So this to me sounds like a big deal and a big breakthrough that you've researched and discovered and have engineered through. And so now you would think that this would be front page news every day, top of the news on every. Why do you think it's not?
Ideological dogma.
So could you expand on that?
The National Cancer Institute and many of the top cancer institutes throughout the world think cancer is a genetic disease. If you go to the website for the National Cancer Institute, you say, what is cancer? Cancer is a genetic disease caused by mutations that lead to damage in the DNA. And the DNA damage leads to dysregulated cells. So you have to say to yourself, what is the definition of cancer? It's cell division out of control, dysregulated cell growth. What is driving the dysregulated cell growth? A fermentation metabolism. How is that possible? Because the organelle that controls the differentiated state is the mitochondria, and it's in the cytoplasm of the cell. That organelle controls division and controls the quiescent state. When that organelle becomes damaged in some way, the cells fall back on these ancient pathways that existed in all of our cells, but they're very minor. But they were major before oxygen came into the atmosphere. So the cancer cells are simply falling back on these ancient pathways. Well, this is a totally different concept than the dogmatic view of what cancer is today, which is a genetic disease. Therefore, the drugs, so-called precision medicine, targeted therapies, they're going after mutations, which are now we have shown and others have shown that when these organelles, the mitochondria, become corrupted, they throw out what we call reactive oxygen species coming out of these cytoplasmic mitochondria. They are the ones that cause the mutations in the DNA. The mutations in the DNA are an effect of the abnormal energy metabolism. They're not the cause of the dysregulated cell growth. So the whole paradigm changes. So
you're saying what the conventional the Cancer Institute say is that this is caused by a DNA mutation, but what you're saying is no, that the cancer actually causes the DNA mutation. Is that what you're saying? Is that what I hear?
Yes. The mutations are the effect. They're not the cause. And so
you come at it from a totally different way than they're coming at it. And what's your success rate? Would you say how many patients? Go ahead.
No, this is another extremely important. We have many obstacles to moving metabolic therapy or metabolic oncology into mainstream. Number one, none of the physicians, very few physicians even understand this. They've never been trained to look at cancer as something other than what the system tells them what it is. So we don't have trained personnel. We have institutions that say it's a genetic disease. We have the whole system is set up for revenue generation to treat cancer as a genetic disease. So you see Opdivo, Keytruda, CAR-T immunotherapy, all these things, they're based on a somatic mutation theory of cancer. And if the somatic mutation theory of cancer is not correct, the outcome from treatments based on that theory will never be optimal. And that's exactly what we see. We see all these poor folks being brutalized by a system treating them for toxicity and hoping to kill the tumor. Yes, those drugs will kill cancer cells, no question about it. But they make you go bald. Your gums are bleeding. Your liver's blown out. Your kidneys are blown out. You have gut problems, the mental problem. I mean, this is all what would be totally expected if the theory under which you're treating the disease is incorrect. So what we're seeing, the cancer epidemic is due to an incorrect theory. And the correct theory is what Otto Warburg said a long time ago, and what our research has solidified, that it's a mitochondrial metabolic disorder. It's not a genetic disorder.
Now, can you is it possible for you to explain to me when you say mitochondria or what is that?
We have a cell, and in the cell you have what they call organelles. And you see a big nucleus. Everybody looks onto a cell and says, what's that big round thing? That's a nucleus. It contains the DNA, chromosomes and genes on the chromosomes. But then you see all kinds of other stuff outside the nucleus. You see lysosomes, Golgi apparatus, endoplasmic reticulum. A lot of stuff is inside the cell, but outside the nucleus. And one of the organelles outside the nucleus is the mitochondria. Interestingly enough, in the evolution of species on the planet, these originally were two different independent species of organisms, but they fused together and formed this hybrid organelle, where you had an organism that could capture the energy of oxygen, which was slowly increasing by cyanobacteria in the atmosphere. And that organelle then transformed this cell into a much more energy efficient kind of a cell. And once you have energy efficiency, that leads to metazoans, which are multicellular organisms. Don't forget, everything on the planet evolved as a singular cell, a single thing. Well, where did we get all these complex plants and animals and all this other stuff? It came from the fusion of one organism, one kind of a bacteria with another kind of a bacteria, but this one kind of a bacteria could capture oxygen and use it for energy efficiency. So then you could get multicellular organisms, and you can begin to see the evolution of species on the planet. The problem is those ancient pathways are present in all of our cells, except they're very, very minor. But when the cancer cell loses that organism, it's kind of like it has its own DNA. It's like a second organism inside of another one. The mitochondrion is like it has its own DNA. It's very interesting. They have relinquished all of their genes to the nucleus, except 13 genes that control the keys to the kingdom. When I say that, when anything happens to one of those 13 genes in this mitochondrion, immediately causes the death of the cell. The problem is if that organelle becomes damaged or corrupted by carcinogens, smoking, hypoxia, all this, it loses control. And what happens then is the cell falls back on the proliferative aspect. They lose control of the differentiated state. And this is exactly what's happening in these cancer cells. The organelle that's supposed to maintain differentiation and homeostasis becomes corrupted. The cell falls back on ancient fermentation pathways, which lead to dysregulated cell growth. Everything is completely explained if you understand evolutionary biology. So once you understand evolutionary biology, then what I'm saying makes perfect sense.
So, I mean, you're not some fringe guy, right? I mean, you're from Yale, you're from Boston University,
Boston College.
Sorry, Boston College. Why? Well, how successful are you at getting your message out? And what do you think is the big stumbling block to getting more people to know about your method for managing cancer?
Well, you're talking to me right now.
Okay.
Right? Okay. All of our papers, all this, we've been working on this for 40 years. I mean, my publications are out there. Anybody can look my name up, and if you think, oh, what's the details? I don't believe what he's saying. Well, why don't you read the damn papers? Read the details of the papers I published. They're open access. Anybody that has a computer can go into Google, look my name up, and say, let me see what he says about the press pulse therapy theory. Let me see what he says about the origin of cancer. It's all there. It's all there. I'm not high. Anybody can read it. The problem is they don't read it. That's the big problem. You got to have somebody reading the papers to understand what you're talking about.
So now, do you ever treat people, or do you advise doctors who treat people?
I can advise. I'm not a physician. I can't treat anybody. I can't tell anybody what to do or what not to do. I can send them literature and knowledge and bring them in contact with some people, but I cannot give medical advice to anyone. That has to be done by someone who's licensed to do that. Now, I do work with a number of physicians who are chomping at the bit to do this. The problem is, they say, where's the clinical trial? I can't believe anything unless you have a clinical trial. Okay, well, who's going to do the clinical trial? And if you don't, and the institutional review boards, the IRB of major hospitals, has to make a decision as to whether or not a particular strategy would be allowed to take place. And what we found in the brain cancer, the glioblastoma field, they will not allow metabolic therapy to be used unless the patient is also irradiated. And we published the brain being irradiated. And I published several papers providing hard evidence in no uncertainty that radiating a brain with somebody with a tumor frees up massive amounts of glucose and glutamine in the brain of the patient with the brain tumor, leading to their rapid recurrence of the tumor and the death of the patient. This type of therapy for brain cancer is present in every major medical school throughout the world. You can go to Germany, Japan, anywhere in the United States. They all have to have their brain irradiated as part of the standard of care. And I have published, when I keep publishing these papers, showing that by doing that to the patient, you have essentially sealed their demise. And you think that somebody would read the papers to see the evidence that I'm giving, and yet they don't. And you say, what is going on here? Why are these institutions so resistant to using metabolic therapy? And it's the institutional system of standard of care linked into all of these different procedures that now would cause it. But I'm just saying get rid of radiation for brain cancer. But I'm not saying get rid of radiation for other kinds of cancers. It might be successful. So I think we need to know how to do this and the strategies that we need to. So you're right. A lot has to change. A lot of people need to know what's going on. And the scientists themselves need to know what's going on, and a lot of them don't.
I mean, we've just at this show, we lived through COVID, and we saw how money is involved with treating things, and the propaganda campaign against ivermectin, for instance, right? So they made you think that ivermectin was this horse paste, as opposed to what it actually is, which is a Nobel Prize-winning medicine that's on the WHO list of essential medicines that's been prescribed billions of times, saved billions of lives. But they made everybody in the United States, at least, believe that if you even mentioned that, you were some kind of a wingnut, and that you're talking about veterinary medicine. That's how powerful propaganda is. And and then they push their medicine that they have. There's no patent, right? So there's no patent on ivermectin. So now this medicine. So now I think
they wouldn't do that just to make money, so risk everyone's life.
So do you think the problem that you're facing is that you're not pushing a pill? And so if you were pushing a pill that a big pharmaceutical of a company could get behind, they would then fund the trials. They would get the places to do the trials because there's money to be made. But the way you're treating it doesn't seem like there's a big cash cow involved, right?
Well, no, it can be, but you're 100% correct. But like for example, a perfect example, the drug I was talking about, DON, 6-deoxynorlucine, it's not patentable. Yet it's extremely powerful and powerfully therapeutic. Okay, however, so you get big drug companies will take that drug and put a little tail on it, a few carbon extra tail, making it slightly different from the original molecule. And now they'll try to treat patients with that because they're arguing that the therapeutic benefit will be maintained, but I've slightly changed the structure of the drug to make it patentable and make $1 billion. The problem is, they don't use the full package of what you need to do. They're going to run into the same problem with that drug as the people did when they used the original molecule. If you don't target the glucose at the same time you're targeting the glutamine, you're not going to be successful. You're not going to have the level of success that you will. So you'd say to the drug, in fact, I spoke to the drug companies. I said, listen, if you take that drug of yours and mix it in with a calorie-restricted ketogenic diet, you're going to get tremendous results. They said, we can't do that. I said, why? Because we won't know if the therapeutic benefit is from our drug or from the diet. And I said, who cares? The patient's going to live longer. And they don't care about that. They only want to know if their drug has any modicum of effect. Yeah, I probably will, but you're not going to achieve the success that you probably could achieve. And then try to do a clinical trial where you're modifying. And we built this glucose ketone index calculator at Boston College with my students. And it tells people when they're in nutritional ketosis. When the body gets into nutritional ketosis, that's when you bring the drugs in at low doses. That's when you get the powerful therapeutic effect. So you have to know how to play different drugs and physiological systems off each other to get the maximum therapeutic benefit. And when you talk to the standard of care, the way they evaluate drugs, it's not part of their paradigm. So again, that's another obstacle to moving metabolic therapy forward, because the clinical trials design has to be completely different. It has to be different from what the system says it should be.
So we're talking about it's a combination of cutting off the fuel through diet for the cancer tumor. Current medicine, the current standard of care is to treat cancer as a problem with your DNA, a mutation of the DNA. Now, your research has revealed that it's actually not that it's actually the DNA gets mutated because of the cancer. And so that most of modern medicine that's treating cancer, the standard of care, is coming at it from the wrong way, and that you come at it through a combination of diet and drugs. And the drug is called DON. So you block the glucose and glutamate. Is that how you say it? Glutamine. Okay.
Yeah.
And this is so there isn't like if someone has cancer, there isn't anywhere they can go for this treatment, is there?
No, well, there are some small clinics that are attempting to do this after they read my stuff, and we're very close to submitting a very comprehensive treatment protocol for glioblastoma, top brain cancer, a deadly brain tumor. But it's the same. One of the things that we found, Jimmy, was that when I did a deep dive on looking at that organelle mitochondria, it's abnormal in all major cancers. So all major cancers that we know of are all doing the same thing to grow. They're using that fermentation, those two fuels. So one cancer is not very much different from any other cancer. And this is another challenge that the field can't understand, because when you look at it from the DNA perspective, they all look different from each other. But when you look at them from the mitochondrial metabolic perspective, they're all very, very similar. So so there's a common strategy for managing these cancers once you know the biochemistry. And the other thing is, don't forget that this concept of mine it was based on the concept of Otto Warburg. And Sam Apple wrote a big book called Ravenous about the history of Otto Warburg. I mean, he was a giant. Don't forget Hitler. He was half Jewish, and Hitler kept him alive during the Second World War in Germany, knowing that if there was ever going to be a solution to the cancer problem, Warburg would find it. The issue is that this guy was a Nobel Prize winner, a giant in the biochemistry field. And all I did was simply confirm that he was, in fact, correct. But not only that, we found out where he made some of his errors, and we corrected them. So it's not like all of this is mine. All I did was take what was already known and just expand it and show that that is the real issue of cancer. Whereas the field ran off chasing genes and doing multi-billion-dollar genome projects and all these kinds of things that are is largely good money thrown after bad. Not to say that that stuff can't help for something else, but it certainly hasn't done anything to manage and reduce the death rate for cancer, that's for sure.
So all this, so maybe you can answer this, maybe you can't. The Komen Foundation and all the money that they've raised to fight breast cancer, It doesn't seem to me, maybe I'm wrong, correct me if I am, it doesn't seem like they've made any progress. And
yeah, they have. And not only they don't make progress, the more money you give to Susan Komen, the more cancer you get. The more breast cancer is now replacing heart disease and a number one killer of women. So what I did as I went to look at Komen, and I said, why are they not making any progress with all the money that people raise for the breast cancer thing? And I looked at their scientific advisory board. I looked up the scientific publications that their scientific advisory board produce in the scientific literature. And it's all that cancer is a genetic disease. So if your scientific advisory board thinks cancer is a genetic disease, you can give $100 billion to the Komen and you're not going to get anything from it. And there's no accountability. Where does all that money go? People running, jumping. They just say, oh, I feel good. You feel that the people who benefit from Komen are the ones who run and jump. They get healthier doing that. But the money they're raising to reduce breast cancer, that's not doing anything at all, because the scientific advisory board itself has a misunderstanding of what the nature of breast cancer is. Metabolic therapy has been very, very successful against managing breast cancer. So clearly, the field has to change, man. It's not on the right path. And Warburg showed, and others, I want to say there's a lot of others out there that are also showing the same thing we're showing, except we're doing a deeper dive. We're challenging what scientific understanding, not the mutations. That's pretty much a done deal as far as I'm concerned. The issue is this new concept of energy metabolism through fermentation in the mitochondria itself. This is new. This is the new thing. So this is what we're trying to establish the scientific evidence for. Because once we do that, then we can put together the problems that Warburg had and why his theory and why his hypothesis was terminated, when we can now resurrect it and bring it back on the right path. But we have to do so many experiments in the lab to prove that, because I am in the field of science. I am a skeptic myself. I don't believe anything until I can see the hard data and the control experiments, and done again and again and again. Show me the evidence. And then we have to prove that to our other colleagues in our field. We have to show them the evidence. And to do that requires a lot of time and energy. So my preclinical systems and my staff, we're working day and night proving that the cancer cell is getting its sole energy from these fermentation mechanisms. So, and we have to prove that with evidence, and that's what we do.
And so, how much longer do you think it will take before you'll have enough of the data that you won't have to keep trying to prove it? It will be proven, and people could just look at it.
Well, I think with our treatment protocol right now, I think once people start using it, they're going to start to see remarkable success if they're allowed to use it. If a medical school would allow it to be done. And that also, because to allow our stuff to be done, it has to be done the exact way we outline. Because a lot of these people, you'll see a lot of these ketogenic diet trials. Oh, ketogenic diet. You hear about all this ketogenic diet. And then when you say, it didn't work, it helped this guy, didn't help that guy. Every time you look at it, they never did it the correct way. You got people who have tools, they don't know how to use the tools. So you have to have the guys who know what to do and how to do it. And we're training those and showing those folks what to do and how to do it. That's the mission of patient outcome. And then we have the preclinical mechanism of action outcome. So we hit the problem from two different directions. One is the basic hard science, and the other is, once you know that, how does it work in the clinic? So you have other challenges in getting people to get into therapeutic ketosis, and what dosage timing and scheduling of the drugs that are needed. It's not just Don. Don is the best for sure, but the drug companies are making all these glutamine inhibitors, and some of them may be very, very effective, but they have to do it with the entire package in order to get the maximum outcome. And if they don't do that, they're never going to achieve what we think can be achieved, which is a reduction in cancer deaths by 50% in 7 to 10 years. This is what, if people did metabolic therapy the right way, that would be the outcome, and you would see the needle drop. You would see a movement of the needle in the correct direction.
So you say 50%. Why wouldn't it be 100% if this is actually the mechanism for fighting it?
Well, you have to realize that some people come into the clinic in all different states of disease. Compliance issues. There are other issues that could at first be problematic. It's going to take several years for physicians to know the nuance of it. It's not a one shoe fits all. Each person has to be screened metabolically before we treat any of the patients. So we do a comprehensive blood work, my colleagues, not me, my colleagues that work under our guidance. So we have to find out how many different metabolic problems these people have. Many of them don't just have cancer. Many of them have type 2 diabetes. Some of them have high blood pressure, hypertension. You have to bring the body into a new metabolic state before you can start hammering away at the tumor. You want those tumors to be extremely vulnerable, not at their strongest, at their weakest. So, and this takes time, but I think if you go to the Cancer Revolution documentary movie that's being made by Brad and Maggie Jones, they are now collecting more and more folks that have been doing metabolic therapy, all stage 4 terminal cancer patients that are done metabolic therapy outside of a clinical trial. So, but they're all alive far, far longer than they would have been had they done standards of care. But they don't believe that because they call each one an anecdote. Well, you give me a clinical trial, I got to see a clinical trial. Well, who's going to do a clinical trial? The system is not ready for the clinical trial.
So you're saying that I know someone who has stage 4 cancer, and you're saying that even someone with stage 4 cancer, which is considered terminal, that this approach could help them.
Yeah, well, here's the interesting thing. Many people, not all people, but they come and they go, oh, I got some lump, I got some bleeding, I got something of this, that. I go down, they do a biopsy and whatever, and they say you have stage 4 cancer. And the guy said, well, I know I didn't feel great, but I didn't know I had a terminal disease. But at that point, they're pretty healthy. That's when metabolic therapy would really have a massive impact. But if they go to standard of care and get radiated and poisoned with these toxic drugs and surgical mutilations and all this kind of stuff, the body is beat down severely. And then you try to rescue that kind of a person with metabolic therapy, your success rate is not going to be as good as if you approach that patient at the very beginning of the diagnosis. So, and I don't like biopsies. I have dozens of papers in the scientific literature showing that biopsy spreads cancer, can spread the cancer around. So why are you doing that in the first place? People got very upset when I said that. I said, why? I'm not saying it. The papers in the scientific literature, all you have to do is the paper. Well, I never saw that. Well, you don't read the scientific literature like I do. So many physicians have done and shown cancer is spread by inappropriate surgical procedures, inappropriate biopsy procedures. Why do a biopsy when you can shrink the damn thing down? And then if it's really small, you have the surgeon take the whole thing out rather than stabbing it and wondering why the person got metastatic cancer. So we've looked into all of these kinds of things. We've got everything there. It's just to manage cancer effectively. It's just that we don't have the strategies in place and let the people know what they should do and should not do under these particular conditions. How long will that take? I don't know.
So, I keep hearing you say the same thing about how people who doubt you, and you go, well, have you read? Did you see it? Are you informed? And they're not. So that's the same.
Why would I be informed?
See, it's very Vladimir Putin. It's very similar to what we experience at this show because this whole show is about debunking mainstream narratives about everything, mostly about war, but politics and COVID and Russiagate, and so so when we tell people that, they look at us like we have 10 heads, and I say, well, did you see this? They're like, no, and I'm like, will you read it? No. And so, hey, did you read the Durham report? Did you read? No, they won't. So so let me ask you this: so this must be unbelievably, extremely frustrating to you as someone who's on the forefront of this kind of knowledge. And people seem to be curious about it. How do you keep your sanity?
My students ask me that all the time because we're doing the research and we're all scratching our head. But this is the history of science. Every time there's been a major paradigm change in the history of science, there's been massive resistance to it for whatever reason. the challenge to the geocentric theory of the solar system, that the Earth was the center of the solar system.
Yes.
The Catholic Church and its power.
Yes.
Giordano Bruno was burned at the stake in Rome for his challenge of that. So Louis Pasteur's germ theory, he was eviscerated by the MDs at that time.
Yes.
The Darwin theory of evolution, eviscerated. The difference between the somatic mutation theory of cancer, which is the current view, versus the mitochondrial metabolic theory, which is the correct view, the difference between these paradigms is that we have 1,700 people a day dying from cancer. In an hour, we're having 70 people in an hour dying from cancer. Those other paradigm problems were not linked to dead people on a daily, hourly basis. So how long do you want to wallow in ignorance because your ideology prevents you from shifting to a new paradigm? People want to live. They're willing to do this if given the opportunity by people who know what to do. So this is the greatest tragedy in the history of medicine, because we have the possibility of keeping people alive. I'm not saying curing them, but we can certainly keep them alive with a higher quality of life and an improved overall survival, better than what we currently have. And we're locked into a dogmatic ideology that prevents this from happening. And as Upton Sinclair said, it's very difficult to get somebody to appreciate something different when their salary depends on them not appreciating it. So we have that issue as well. So there's a lot of issues.
So what would be your advice to someone who is diagnosed with cancer? Somebody watching this show just got diagnosed with cancer. What should they do?
Well, this is, everybody says that, they say this guy talks the talk. He gives you all this information, and then where do we go? And the answer is, why don't people write to the head of the National Cancer Institute and let them know what the hell is going on here? You guys have a tag on your thing saying it's a genetic disease, and if you sit down and look at the evidence, it's not a genetic disease. You guys have to get your acting together. And don't forget, Jimmy, in 1984, the progress in cancer research was done primarily by the government, the National Cancer Institute. In 1984, the progress was considered too slow, so they invited the pharmaceutical companies into the academic institutions to facilitate the development of drugs. How's that working?
Yeah.
How's that working out today? Not good. Okay, so you have a lot of major systems in place that are resistant to this kind of a change. The only thing that we have on our side are people that want to live. Bottom line, I want to live. I want to see my sons, my grandchildren. I want to see my loved ones live a little longer and not be brutalized by a system using incorrect tools in the incorrect way. So how long will that take? I don't know. Okay, who's going to step forward and do a trial? Well, I'll be happy to, once we have the protocol. The problem is you can't do that. It's always you can't. I talk to these guys. Oh, you can't do that. Oh, you can't do this. Oh, the system says you have to do that. I'm saying, man, people want to live here. Don't you understand? People want to live. You're telling them they can't do that. They can't do this. If you do it the way we say you do it, you're going to live longer and you're going to have, but that's not the way we do things. Well, I'm sorry. People are dying and I that's what kills me. When I see all these letters coming to me, hundreds and hundreds of letters, sometimes I stop and I have to take a breath. I can't read any more of this tragedy. The torture of what these people are going through. The Spanish Inquisition could not torture some people as bad as what we're doing to some of these cancer patients. So it's absolutely incredible. And we don't have to be doing that. That's the key. Yes, you want to know the frustration? We don't have to be doing this to people.
It sounds pretty frustrating. So, all right, well, if people want to find out more about your work, where should they go?
Well, I mean, as I said, we have my book here, and everybody, many people get upset because John Wiley Press, which is a dominant publisher of scientific academic science books, it's $150, $100 or something. It's not like something you can, pick up off a airport newsstand. But that has a lot of information in it. We get support for our research primarily from private foundations and philanthropy. I'm always wondering why they give hundreds of millions of dollars to some of these cancer institutes and no one asks for accountability. It's like, where does all that money go you give? And every year we get more cancer. Nobody's given me $10 million to do. If we had that kind of money, we would hire more postdocs and we would set up clinics and we would start testing people the way we think we should be testing them. So the solutions are all there. It's just that we have to put the package together. And I don't want to call it a solution. I would say a great advance in management. Let's put it that way. A great advance in management.
Okay, Professor Thomas Seyfried, I really appreciate you coming on. That's the book, Cancer as a Metabolic Disease. And I really appreciate you doing that work. And if you have any more stuff you'd like to talk about, please let us know. We'd love to have you back on.
Well, thank you very much, Jay. Thank you very much for having me here.
Hey, come see us live on tour in Los Angeles, Palm Springs, Stockholm, Amsterdam, Rotterdam, Berlin, Copenhagen, Oslo, Stroudsburg, Pennsylvania, Cortland, New York, Oakmont, Pennsylvania, right outside Pittsburgh, El Paso, and San Antonio, Texas. Go to jimmydore.com for a link for all those tickets.